Hey everyone, Nitesh this side. Hope you are doing good. So let's start with the question. So the question is shortest path in a binary matrix. So what is given to us? We have given a matrix which is n cross n binary matrix. So it's only containing 0 and 1. So what you have to do, you have to return the length of the shortest clear path in the matrix. Okay. So if there is no clear path, return -1. So what we have to return, a clear path is basically mean from the top left cell, that is 0 0, to the bottom right cell and -1 and -1, basically right bottom. So what you have to do, you have to do all the visited cell of the path are 0. Okay, so you have to find the path from top left, basically 0 0, to the right bottom, which is n-1 n-1. You have to find a path between them, and the path only containing 0 in that, and you can go in 8 direction. Basically you can say like top, left, right and right diagonal, all the 8 direction you can go. What you have to do, you have to return the length of the clear path is the number of visited cell of this path. Okay, so you have to give an return how many, basically you have to return the number of visited cells that you will take to give this path. Okay, so let's understand with an example. Okay, so we have given this matrix basically. So this is, you can say, you have to start from here and you have to reach here, and you can go in all 8 direction. So this, if let's say you are at here, here, so you have this direction, you have this direction, you have this. So this is the 4 direction, and you have two more, basically 2 diagonals. So by this you have 8 direction. You can go anywhere. So if we can see, like can we go here? No, we can't go here. Can we go here? No, we can't go here. Can we go here? Like it doesn't make to go here, like you don't have any element there, so you can't go here and here also. So you can only go in this direction, and you can see this is 0, so you will come here. I will check whether you visit at the end of the array. So you can see this is the top right, so you can just, and you use 2 cells, this is 1 and this is second, so you have to return the how many cells that you use, so you return the output as 2. Okay, let's see with another example. So again we will start from here. Okay, so from here we can go in all direction, like these are the valid, this is not valid because this is out of array. Okay, so we can see this is 1, this is 1, so we can't go in this, we only have option for this. Okay, so now we'll move further. Again we have 3 direction, no 3 direction, 1 2 3 4 5, and others are invalid. So you can see we have 2 options, either we can choose this or either we can choose this, because these 2 are invalid and this is already visited, so we'll not go backward. Now we have 2 options. Okay, so if we go by this, so if we go here, then we have to again come here. So you can see we are taking an extra cell which is not necessary, we can directly go here. Okay, so we can skip this. So when we come here, we have again an option, so we can go in this direction, so we go over here and we reach at the destination. So if you can see we are using 1 2 3 and 4, so this 4 as output. If we go from here, let's say we choose this, so we take a new, like one more cell. So after this we will go again in this direction and then this. So for this, if we go with this is 5, but we need to give the shortest. We don't need to just return the, like whether it is reachable or not, we need the shortest one. Okay, so let's see this also. So we have given this example 1 0 0 1 1 0 1 1 0. Okay, so we need to start from here. Now you can see if we have to start from here, this element should be 0, and your basic and your end should also be 0, like it should be also 0. If both of them or either of them are 1, you can't find a path, you just have to return -1 for that case. And if you, after solving, like you come here and you didn't find a path, then also you have to return -1. Okay, so let's see, I hope, like how we can approach the question. So okay, so we have several options to solve this question. Either we can go with DFS, like depth wise, either we have BFS, and we have Dijkstra also. Okay, so let's see whichever gives the best. Okay, so first let's see for DFS. Okay, so for DFS, as we know, like if we are going from here, we will either go in only one direction, like after solving from one direction we will come back and then we will go to other direction. So as you can see, like if you are at here and let's say you go here, you go here, like you have an option, either you can go here and here. Let's say you will go here and you go here, then you reach it, so you got output as 5. Then you come back, come back here, you again have an option, you will go here, so then you will get a 4. So you can see like this is small depth, but let's say if your depth is very high, like then why you have to go in depth wise? You can always, like if I have an option, I will choose the best one, so why I have to traverse all the direction? So you can solve the question with DFS also. Then always you have to take a maximum variable, so you will get the output always as, like whenever you reach here you will got your output, but you have to update your maximum every time because there are several paths you can reach. Okay, so this is the one approach that you can also use, but there is some better approach we can go with. We have a DFS and we have a Dijkstra. So generally both are used for like shortest distance. Okay, now like what's the difference between Dijkstra and BFS? In Dijkstra we have a special property that is we use a priority queue or a heap. Okay, so we use a priority queue or heap. But why we use this? Because Dijkstra we generally use for that graphs which have, you can say, different weighted edges. But in this you can see all have, let's assume this is a graph, so this is having a edge 1, like go from this to this. This is also 1, this is also 1, this is also 1. So you can see like we don't need a priority queue, we can go normal with a BFS. So with this, like you can, like we can go with Dijkstra, but writing the code of Dijkstra it's difficult than BFS, so it's easier that we can go with a BFS approach. Okay, so let's see, like we neglect DFS, now we neglect Dijkstra. Let's see how we will solve with BFS. Okay, so we have this question, so let me just 0 0 0 1 1 0 1 1 0. Okay, so what I will use for BFS, we use a queue. Okay, so let's take a queue and we'll go by level. Okay, so we will start from here, we will initialize, so we will, let me give the indexing also 0 1 2 0 1 2 and we'll push it, so 0 0 we will push it in the queue. Now we will go for each level, so and we will mark this as visited. Let's just take a true. Okay, this is visited. So at h, like sorry, it will be like at every level we will go, like we will pop this and we will insert its neighbor. So we have three options, this. We only insert the 0th neighbor. So we will insert this. So this is 0th row, 1 column, we will insert it. Now we'll move further. From here, we come here, we mark it true. Now again we have two options, this. All are invalid because this is 1. So we will pop this and we'll push both of them. So we'll push 0 and we'll push this. Okay, so what we will do, we will push this 0 3 0 2 and we'll push also 1 and your, it will be, and 1 and it will be 2. Okay, and we will take a result variable also. So till now, like you start from 0, you come at here, so this will become 1, and after this will become 2. Okay, so we have done with 2 level. Now we have two neighbors. Okay, so we have pushed it in the queue and we'll mark them visited, true, visit. Now we'll solve first this two levels. Okay, we will not go further, we will solve first this level. So how we will solve this? Now we will pop this. Okay, we will pop this, so this having this direction and this having only this direction because this is already visited. Okay, so now it's saying like you will insert 1 2. Okay, now you can see that 1 2 is already in your queue, so you will not basically you mark this already as visited, so you will not push it into the your queue. You will just directly, you can say, skip this and you will insert, you will come here. Okay, so we will do for 1 2 have this option, so this, so we will push this, so we will push 2 because this is not visited. We will push 2 and we'll push 2. Okay, so and you can see this is your, and you, then after this you will increment your level. Okay, and you can see this is your final destination, so you just return your result 3. So after this you will do +1, you will get a 4 because we are starting from the 0. That's why I'm doing +1. Okay, so it will be more clear if we write the code for this. Okay, so let's write the code. So we'll write with a BFS, so we need a queue for that, and your queue will be of array. Basically array will have x and y. New linked list, and let me take the base case also. So grid dot length, if my grid 0 0 is not equal to 0, or grid of either of one of them, n minus 1 or n minus 1. If any of them is not 0, then you can't find a path, you just return -1. Otherwise we'll do our solve the problem. Okay, so what we need, we'll take a result variable which will start from 1. Okay, basically if we go from 0, we have to do answer +1, otherwise we are using our result equal to 1. So what we need to do, uh, we'll take a boolean visited array also. Boolean visited, new boolean n. Okay, now first step is to push everything first in your queue. New int will push 0 comma 0, and will mark visited as 0 0 as true. Okay, now we'll loop over our queue. So while queue is not empty, we'll do something. So for every level we'll loop over inside that. So for int I q dot size -1, I greater 0, I minus minus. Okay, so after every level we will update our result by ++. So like in the question we need to return the cell. Like if it is edges, like you can see this is only one edge but output as 2, so that's why I'm taking result equal to 1. Okay, so now what we will do, we will pop the element. So int pop equal to q dot remove. Okay, so our x will be pop of 0 and our y will be pop of 1. So what we need to check, whether this x is okay. Yeah, if this x equal to n minus 1 and y is also n minus minus 1, we'll just return the result from here. Otherwise we'll need to go in all 8 direction. So what we will do, so we'll loop over to k direction, k less than 8 and k plus plus. Okay, so for this let's create a array. So it will be like, if you have no, like this will be your, you can say a graph. 0 0 will be initial, and let me just do it like this. So this will be like, if you have to go in the right side, you will increase your column. If you have to go downward, you will increase your basically row. If you have to go in the left side, you will decrement your column. So 0, row will remain same, column will go. Then this, you can say this will become, if you have to go on the top, so you have to reduce your -1 and 0. So similarly, this will be like your row will come first, so -1 1, and for this will be 1 1, For this, it will be 1 minus 1, and for this, it will be minus 1 minus 1. Okay, so we can write this in a array and we can solve the 8 direction. Okay, so we got our 8 direction. So we'll find new x equal to current x plus direction of k 0. Basically 0 will represent x and 1 will represent y. And we'll find a new y also. Y plus direction k of 1. Okay, so it should be like, it should not be visited. So visited of new x and new y, it should be false, and the current grid like this new x new y should be 0. Then we'll insert in the queue new y, it should be 0. Okay, and we need to check the invalid condition. So new x greater equal to 0 and new x less than n and new y greater equal to 0 and new y less than n. Okay, so if that true, what we have to do, we just push it to our q dot add new int new x, and we'll push new y, and we'll mark this as visited also. So visited of new x new y equal to true. And after like you didn't come to this x is not equal to n minus 1 and y is not equal to n 1, you finally just return the minus 1. Yeah, I think we have covered all the cases. Let's run. Okay, let's see. Yeah, this is accepted. Let's submit it. Yeah, so our code is submitted. The time complexity is like at best, like at the worst complexity, you have to, if you say for worst, you have to traverse maybe 2 whole metrics. So that will be n square, but there is an option for like you got the diagonal path or you got like a small path then n square. So at best it can be order of n. So yeah, and space we are just taking a queue, so that will also store like all the element inside it. So at worst it will be also order of n square. So yeah, hope you like it. Thank you for watching, and do join the Telegram group if you have any doubt, any concern. Thank you.